Uh, Good morning, all my dear students. That's why good afternoon. Here now the microprocessor lecture is going on. So, dear students, please respond me. Am I audible? And my screen is visible to you, please. Hello, please. Am I audible, dear students?
Yes, sir.
Okay. Okay, dear students. Already we have started 8th unit in the last lecture. So in that 8th unit, we are going to study just operation modes of 80286 and architecture, real address modes operation, protected mode operations we studied. So yesterday's this much portions I have to cover means the last lecture, introduction to 8086, architecture of 8086 to 86, real address mode of operation, protected mode operation. So only the architecture 80386 and 80486 is remaining. So if we have to cover these two architecture 386 and 486, then it means that we have to complete it all 100% theory part. Okay. So this is the thing. In the last unit lecture already, I sent you a notes, right? So now I will open that notes. That is okay. So this is the notes, whatever we yesterday From yesterday we are studying 80286, that bus unit, instruction unit, execution unit, and address units of 80286 we have to study. And pin configuration, that is 80286 pin configurations we have to study. So this is the pin configuration of 80286. And next we have studied architecture. This is the architecture of 80286. That one also we have to study. In that, instruction unit, execution unit, and that instruction unit, sorry, this is address unit, execution unit, instruction unit, and this one is the bus control. So all these architectures we studied in the previous lecture. Along with that, we studied real address mode operation. So these are the real address mode operations we studied. That is trap and exceptions we studied. That is fault and trap with the exceptions we studied. After that, in the previous lecture, we studied protected mode operation. So it is a 8086 protected mode operations, and this bits also we have to explain in detail. Along with that protected mode operations, we studied memory management of 80286. This is for extra, just I have to bear you for your understanding. Okay. So today I have to start with 80386 architecture as per syllabus. So this is the syllabus. Today I'll start with 80386 architecture as well as 80486 architecture. So these two I have to cover in today's class. Here there is no any protected mode or real address mode or any kind of introduction. Just we have to look into the architecture of 80386 and the architecture of 80486. Okay. So this is the notes. Now again we will start with 80386 architecture. So in the 80386 architecture, mainly it is divided into three sections. That is central processing unit. Central processing unit, what it will do, all it will manage the things. That is ALU, bus control, everything. Okay. And memory management unit. In this 80386, we have to study memory management also and bus interface in it. So in the 80286, we studies bus interface unit, memory management unit, central processing unit, and execution unit, address unit, right? Address controller unit. But in the 80386, please be remember that these three main parts we have to study. That is CPU means central processing unit, MMU means memory management unit, and BIU means bus interface. So here at first one I have to consider, that is CPU. So CPU is the further divided into again two main parts, that is execution unit and instruction unit. In the 8086 second unit, also you studied execution unit and instruction unit, bus unit, right? BIU, bus interface unit. But here in the 80386, we have to study just execution unit and instruction unit under the CPU control unit. Okay. So in that execution unit, it has 8 general purpose and 8 special purpose registers, which are either used for handling the data or calculating offset address. What is offset address? So after the address lines, whatever the instruction pointers you have to use, that is nothing but offset address. So in this execution unit, there are 8 general purpose registers and 8 special purpose registers. Along with these 8 plus 8, the execution should be happened in the 80386. And next one, that is instruction unit. So in the instruction unit, it decodes the opcode bytes received from the 16-bit instruction code queue and arranges them in the three instructions, that is decoded instruction with the instruction queue. So that is the mainly take care of instruction units. So in the central processing unit, after decoding, it is passed them to the central section for deriving the necessary signals, the barrel shifter, and increases speed of all the shift and rotate operations. So shift and rotate of instructions you studied in the third unit. So those are helpful for in the central processing unit for coding and decoding with a control section. And here in the multiple and divide logic implements the bit shift rotate algorithm to complete the operation in minimum mode. Okay. So that is to complete multiple and divide logic implementation in the rotate algorithm to complete all the operations in the minimum mode time. And in the central processing unit, there is a even 32-bit multiplications can be executed within a microsecond by multiplied or divide logic we have to use it for 32-bit multiplications. So the memory management in it that consists of segmentation in it and paging in it. So memory management mainly it is to take care on the paging in it. That is the segmentation in it which can allows the use of two address components that segment data, offset for reliability, and sharing of code and data. So the segmentation in it allows segment of sizes of 4 bytes at maximum size. And the paging concept, whatever used in the paging concept, that is it units organizes with the physical memory, and in terms of phases are 4 kilobyte size each. Paging unit works under the control of segmentation unit, that is each segment is further divided into pages. So the virtual memory also organizes in terms of segments and pages by the memory management. Okay. So the segmentation in it provides a 4-level protection mechanism for protecting and isolating the system code in the data from those of the application program. So that may be happened in the segmentation. So the control and the attribute which can actually privilegation at the level of page level. Each of the pages maintains the paging information of the task and the limit and attribute with the segment limit and attributes of uh, PLA means that is a page limit segment level, and it avoids the access to the code and data in the memory segments also. So the bus control unit has a prioritizer to resolve the priority of the various bus requests. This controls the access of the bus, the address drives, and the drives the bus kernel and address signals from A0 to A31. It means that totally 32 address lines it is covers. So the pipeline and dynamic bus sizing in it handle to related to the control signals, that is for bus control in it. So in that, so the hash indicates what along with the address in the bus control, it indicates for bar signals with the ready hash means ready bar. Either you have to use a ready hash or ready bar. So the data buffers and the interface in the internal data bus with the system bus. So here some of the pins we are used in the. So this is the architecture. Architecture I have to explain you. This is the 80386 architecture. Okay, before that we have to discuss what are the pins used in the 80386. So in the 80386, the clock generator we are using, it is the input pin, provides basic system clock timing, and D0 to D31. These 32 lines are acts as bidirectional data bus during the different access cycles. So A31 to A2 to A31 address lines. These are the upper 30-bit address buses what we used in the architecture of 80386. So the BE0 to BE3 bus enable with a 32-bit data bus supported by 80386, and the memory system of 80386 can be viewed as a 4 byte wide memory access mechanism. So here in the address status, output pin indicates that the address bus and the cycle definition pins are carrying the respective hazard signals with this read and write hash, direct and connection hash, memory and input output, bus enable to bus enable 3. Hash means either you have to use for the bar. That is address lines or address status output. So next you saw that ready pins we used in 80386 also. The ready pin signals that indicates to the CPU that the previous bus cycle has been terminated and the bus is ready for the next cycle. So the signals is used to insert wait status in a bus cycle and is useful for interfacing of slow device with the CPU. So as we know VCC, it is a power supply. That one we have to use it with the system supply for supply lines. And VSS is a ground that returns lines for power supply. So B16, this is the bus size of 16 input allows the interfacing of 16-bit devices with the 32-bit wide 80386 data buses. So in the BS16, that successive 16-bit bus cycles may be executed to read 32-bit data from a peripheral and hold signal. The bus hold input pin enables the other bus masters to gain control of the system bus if it is asserted. So the hold acknowledgement, one more we have to use the pin. This is bus hold acknowledgement pin. Output indicates that is valid bus hold request has been received and the bus has been relinquished by the central processing unit. And the busy signal, which can indicate to the CPU that the processor is busy with allocated task. So the error signal, the error input pin indicates to the CPU that the co-processor has encountered an error while the executing its instructions. So this is error pin is very important while it is finding the fault and trap with the encapsulation, that exception handling duration. So next one is a PRQ, that process request output signal indicates to CPU central processing unit to fetch a data word for the co-processor. So next one is the 15th one, interrupt is a maskable interrupt that can be masked using the interrupt flag of the flag register. So next is non-maskable interrupt. This interrupt means maskable interrupt and non-maskable interrupt. So we have to use it for to find the abnormalities and to get the solutions and easily to execute the program purpose we are using. So next one is the reset. A high at this input pin suspends the current operation and it restarts the execution from the starting location. So that N bar C is nothing but it is a no connection. Pins are accepted to be left open while the connecting 80386 is the circuit. So these all 18 pins are carefully you have to study in the 80386, and this is the bit explanation part of architecture. Three parts, that is central processing unit, memory management unit, and bus interface unit. So by knowing this much theory, next we will look into that architecture So this is the architecture of 80386. Okay, so this is the architecture. Just to look into here, uh, this architecture, anyhow you have a online examination, and this is not asking, just for your knowledge purpose. You have to study this architecture, segmentation in it, paging in it. So what you studied up to now, all the units, right? Segmentation unit is here, paging unit is here, internal control bus, this one, request prioritization, hold is there, interrupt, no, maskable interrupt, non-maskable interrupt, errors, busy, reset, hold acknowledgement, B0 to B3. All these explanations already I have to explain and given in the notes. Go to above pins. All these are I have to explain. So here the effective address buses we are used. Effective address bus for the three input address, descriptor register, limit and attributes pin, and here this is also displacement bus and barrel shifter address, multiply, divide, register, find, that is ALU, status flag, ALU control, decode and sequencing, control room is there. So this is the control bus, instruction, code and instruction prefetcher. So code stream, 16-bit code. Just each of the blocks you have to explain in one or two lines. That is more than enough. But for your exam point of view, there is no chance to ask such kind of questions. For only MCQ purpose, they have to asking. So dear students, this is your architecture of 80386, and this all are above is explanation. So please carefully listen. This is the architecture of 386 at this last page, and here you have to come to know that this is all are the explanations of 80386. So that is as per our syllabus. Uh, this is about 80386 architecture. So next I will go for 80486 architecture. So before that, what you will do, take now it is 37. Take 13-minute time up to 320. Up to 320, you have to go through these notes. Whatever I send through the notes, you just scan for 15 minutes in 80386. At exactly again 320, I have to start with the last topic, that is 80486. So dear all students, you have to study this 80386 as per my notes. Exactly again, I'll start, don't go log out at exactly 320. I have to start 80486 architecture. Okay, please all of you go with this up to 15 minutes. Okay, so dear friends, this is your 80386 architecture. So now I will move to as per your syllabus. Uh, that is okay. So now I will move to 80486 architecture. So in that 80486 architecture, here I have to prepare some slides. Okay. So these are the regarding 80486 microprocessor. So dear students, this is the one well defined. So please, am I audible?
Yes, sir.
Hello. Okay. So this is the last topic for your entire syllabus of the 8th unit. Okay. So now we are moved to 80486 as per your syllabus. 80486 architecture. This is last topic of 8th unit as well as the last topic of whole syllabus. So this is the 8086 architecture. Just to we first study the theory part along with this. So it is a 32-bit and it is having a next evolutionary setup from the 80386. So one of the most obvious features included in the 80486 is it is a built-in with a maths core processor. So it is a very main important concept that is built-in math core processor. So in this core processor is essentially the same as the 80387 microprocessor, which is used with the 80386. 80387 with the 80386, that is mainly for the math coprocessor, and it is being integrated in the chip, allows to execute math instructions about three times of the faster than 380 and 80387 combinations. That's what the 80486 is a more popular because of speed is increases. And in the 80486 is an 8 kilobyte code and data cache is there. So to make room for the additional signals, the 80486 is packaged in a 168 pin, and this pin grid array packages instead of the 138 pin used to 80386. So this is the architecture. Just for many blocks, I have to show you in the 80386. Same blocks you have to use it. Along with that, 32-bit data buses, 32-bit data bus, and barrel shifter, register file, base index, bus 32-bit, and segmentation unit, description register, and linear address, paging unit, translation, local local side. Okay, these are the architecture for the 80486. And in these blocks we have to explain, that is containing all the pins. So this is the pin diagram. So it is bit outstanding, but all pins are present over here. I'll make a edit and I'll resend you this slide. So for that pin configurations of 80486, 8 A2 to A31 address outputs, that is A2 to A31 provides the memory and the input with the address during the normal operation. And during this cache line invalidation, A31 to A4 are used for drive to the microprocessor. Next one is M3 to A20 data pins. These are the address bit. 20 mask causes the 80486 to wrap its address around from location, that is 00 to FFFH to all 00, and is an 8086. Okay. and this provides a memory system that functions like 1 megabyte real memory system into the 8086 processor, and the address data stored become logic 0 to indicate that the address bus contains a valid memory addresses. So this is the pin diagram, and in the hold pin, the address is hold input causes the microprocessor to place its address bus connections at their high impedance state, with the remainder of the buses staying active. It is as often used by the another bus master to gain the access for a cache invalidation cycle. So the bus request, this bus request output indicates that the 486 has a generated in the internal bus requests, and the byte enable from B0 to B3 that output select a bank of memory system whenever the information is transferred between the microprocessor and its memory and input and output. So the bus enable byte enable signal enables us D24 to D31 address data lines, and BE2 enables us D16 to D23, and BE1 enables D8 to D15, and BE0 enables D0 to D7. So totally D0 to D31 with BE0 to BE3. So next one, uh, in the blast, the bus last output shows that the bus to bus cycle is complete on the next activation of bus ready signals. So next one is the back off. B off means the back off input causes the microprocessor to place its buses at their high impedance state during the next cycle. The microprocessor remains in the bus hold state until the back off bar pin is placed at a logic level 1, and the non-maskable interrupt also we have used in the 80486. The non-maskable interrupt input requests a type 2 interrupt. So here the pin definition, that is burst ready input is used to signal the microprocessor that a burst cycle is completed, and the cache enable KEN means it's a cache enable input causes the current bus to stored in the internal. So the lock input becomes a logic 0 for any instruction that is prefixed with the lack of lock of prefix. And WR means read and write. The current bus cycles either it is a read or a write, it will decides. So next one is ignore. The ignore numeric error input causes the coprocessor to ignore the floating point error and to continue processing data. So the signal does not affect the state of the uh, PF error. Okay, and flush, the cache plus input process the microprocessor to arrange the contents of the its 8K bytes internal cache, and E adds it's the external address. E adds means external address to input is used with the hold to a signal that can external address is used for to perform a cache invalidation cycles. So next one is P error means F error means floating point error. Whenever the floating point number is going to be executed, that time the output indicates that the floating point coprocessor had detected an error condition, and it is used to maintain the compatibility of the DOS software, disk operating system software. And BS8, this is the bus size 8. BS8 means bus size 8, and BS16 means bus size 16. These two are causes the 80486 to structure itself with the 8-bit data bus to access byte-wide memory and input and output components. So here in the bus size 16, input causes the 80486 to structure itself within a 16-bit data bus to access worldwide memory and input and output components. So here in the P check, that is a parity check output, indicates that the parity error was detected during a read operation, and for the pin number P0 to P3. So next pin is plock. It is a pseudo lock output. Plock means pseudo lock output indicates that the current operation requires more than one bus cycle to perform, and this is the signal becomes a logic 0 for arithmetic coprocessor operations and access 64 or 80-bit memory of data. So here that is a PWT. The phase PWT means what? Phase right through output. So in the PWT right through output indicates the state of the PWT attributes between the phase table and entry for the phase directory entry. Okay. So next ready set, it is ready to indicates the non-burst cycle for to complete the ready signals must be returned with microprocessor, and it is places wait states into the timing until the ready state is asserted. Okay. So the memory input and output that defines the whether the indicate address bus contains a memory address or an input and output port number, and it is also combined with the read and write signals to generate memory and input and output and to control signals. So these are the some extra things are there, though so these are not needed. Just for this much purpose, you have to study for 80486. So this is all about 80486. So dear students, by today this lecture, I have to complete it all 100% theory syllabus as per PH University prescribed. I have to complete it all 100% theory syllabus, and only these many programs are remaining, and the program number 11th and 12th we don't go for because anyhow in our syllabus they are saying only 8 to 10 experiment. So already 9 experiments we have to cover, and tomorrow one more lab sessions I have to conduct it, and in that lab session I will cover this program number 10, that is displaying the string. Tomorrow I have to complete it all the lab sessions of 1 to 10 program as per syllabus prescribed. They are mentioned 8 to 10, but as per my aim these two programs also I will cover it just for the theory part, because these two programs are based on the kit you have to use for keyboard sensing and 7 segment display. So these two theoretically I have to explain. So tomorrow I will go for this experiment number 10, that is program to display the string. So by tomorrow we have to complete it all the 10 experiment of labs, and one more lecture I have to take it, and I have to complete it these two programs also. So for my side, I have to complete it all 100% syllabus. So please you have to take care. Okay. So dear students, today's lecture I have to cover these two topics of the 8th unit. So please you have to go through it, and clear notes also I have to send to you. So please you have to go through my notes. By today, I have to say you all 100% theory syllabus I have to complete it about microprocessor. Is it okay? So please respond me, anyone?
Okay, sir.
Okay, and other apart from this also, if you are facing any problem, because this month end you have theory semester and examination, and before that we have to conduct your second ISC test and your POE practical overall examination. Okay, so second ISC test I have to give you the syllabus for unit number 5, 6, and 7. Unit number 5, unit number 6, and unit number 7 is your syllabus for second ISC. Maybe on 10 to 12 in this month, 10th date to 12th date of March, you have a second ISC. Please be careful. And before that, uh, tomorrow all of you be ready for this experiment number 10, and remaining 11th and 12th experiment also I have to theoretically explain you, because through the kit it is not possible in the online. Theoretically I have to explain 11 and 12 in the later, and tomorrow I have to complete this 10th program. So please Still only 1 or 2 lecture I need to complete it, that 100% lab also. Cooperate me. After that, you will go for a second ISC, you will go for practical overall examination, and immediately after that, you will go for semester end examination. Okay. So from my side, I have to complete it 100% theory syllabus by today's lecture. Okay, thank you all. So I have to stop it here, my today's lecture. Thank you all, and tomorrow also same time you be active and alert, and that time I have to complete your lab session also. So thank you all. Thank you for your cooperation to completion of the syllabus. I wish you all the best for all the theory topics, whatever I have to cover it. Thank you one and all. Now we can leave. And at uh, 4 o'clock, some other means 3:45, some other lectures are taking. Please you have to join with next lecture. Thank you all. Now we can leave.